So let's say I had x squared plus 1 to the 4th times 3x squared minus 2 to the 3rd. So that is product rule, because you have a function of x, another function of x that are being multiplied together. But within that product rule, you're going to have to use chain rule twice. So, like, product rule starts off 2d1, but when you do the derivative of this first thing, you're going to have to use chain rule. Plus 1d2, when you do the derivative of the second thing, you're going to have to use chain rule. You can get into the whole u du thing, or hopefully some of you it's getting easier for you to do them kind of without writing that down. But it's fine if you need to. So let's just start going. So the second thing times the derivative of the first thing. So if I'm going to take the derivative of this, I can go off to the side and go, okay, my u is going to equal x squared plus 1. So du is going to equal 2x. And work this out, do the whole thing over here, and say, okay, that means y equals u to the 4th. Y prime equals 4u to the 3rd times du. And then plug back in. I'm just afraid if you're doing that for every one, it's going to take you a really long time to do them. So I'm hoping that you're getting a little more used to the idea of, okay, what's the big guy here? The big guy would be the 4. How do you take the derivative of a 4th power? Well, you bring it down, you reduce the power by 1. Remember, we leave Mr. Packard alone. Don't be a bully. And then we multiply by the derivative of the inside. So like this gets you to the same, wait, this should be 3 here. This gets you to the same spot. This just gets you there faster. And I hope you're getting more toward this, but if you're not, it's not wrong, it's taking longer. So this is the second thing. This is the derivative of the first thing. Plus the first thing times the derivative of the second thing. So if I try to talk through this without doing all that stuff. Again, your big guy is a power. How do you take the derivative of powers? You bring them down and you reduce by 1. Leave the inside alone. And we multiply by the derivative of the inside. And so this is your d2. Now that stuff's not anything new, it's just combining two things we've learned. We're not done. Questions on that stuff though? So then the simplification rules, what I want you to do here is to get this in one term. How many terms are in that right now?
6.
2. Terms are separated by plus and minus signs. This is all one giant multiplication. That's one term. Plus, this is all one giant multiplication. That's one term. There's only 2. We want to get it down to 1. What can I do to do that? Did you say Adam? There are no like terms. You want to like cube that, multiply everything out, and you're welcome to. Come back to me like Thursday, let me know what you got, and we I mean, there's nothing wrong with that, it's just a pain. And that's not how the AP test would write them. What you can do is reverse distribute. So just like a smaller example of that, if I had, 6x squared plus 4x, what can I take out of both of those? More than 2x. And then what would be left is 3x plus 2, right? So that if you distributed this back, you would end up with what you started with. So we're going to do the same thing here. What we're going to be pulling out is just the giant chunks that are in common. So this 3x to the third minus 2, there's 3 of them there, and there's 2 of them there. So I'm going to take 2 of them, pull them out in front, and then those are basically gone. And how many of these are there now? Now there's just one. Just erase that. What about the other chunk? How many of those can I take? I can take 3, right? Because there's 3 of those here and there's 4 of those there. So I can take 3 of them and put them out in front, which makes these go away and makes this a 3. Oh, it'd be 1, yeah, sorry. Because I took 3 of them out, so there's 1 left. You're right. And every time you do it, it should be kind of the same pattern because whatever, like if I have, I had 3 of these here, there's going to be 1 less than that here because that's the way the derivative works, right? Like you're subtracting 1 from the power. Or there are 4 of those there, so there's 3 there. They're always going to be different by 1 because when you take the derivative, you're subtracting 1 from the power. Stop sneezing. We're trying to make a video here. Jeez. Oh, bless you. Any questions on that stuff? So then I'm going to take the stuff that's left and combine it inside of the bracket. So I'm going to have 3x to the third minus 2 times 2x. Plus, oh yeah, times 4. Plus this x squared plus 1 times 3 times 6x. How many terms do we have now? You have 1. This is all one giant multiplication. So technically, you could be done here. And if it's on like a free response, you can leave it. If it's on my test, you can leave it. But on the multiple choice, they would keep going and work out that stuff in the parentheses. Oh yeah. So they would then go, okay, I'd probably say that's just 8x. Distribute it through, so 24x to the 4th minus 16x. Okay, that's 18x. If I distribute that through, 18x to the 3rd plus 18. And then that's what the answer would look like on a multiple choice. So you could stop here if you're working on a free response. If it's multiple choice, you're going to have to work that out to like match up with this. But what'll happen a lot on that is, like once you get that, just the 24x to the 4th, you can choose the right answer from there anyway. So you don't always have to work out the whole thing, but it's not a bad idea to make sure you're on the right path. Questions around that? What doesn't make sense? So we're combining 2 rules we know, put them together, which is tougher. And then this factoring out part makes it a little tougher. That's just right in the form we want. The reason we wanted this form, because I'm surprised no one's like, well, why would we do this for? We're going to have to, there's a ton of times in this class we have set the derivative equals 0. For example, if I asked you to find when the slope is horizontal, you can take the derivative and set it equal to 0. And if you have it all in one term, let me go off to the side here again. So if I have like x minus 3, x plus 4 equals 0, what are the 2 solutions to that equation? 3 and negative 4, right? And when it's written like this, you can just kind of tell what they are. Because you're setting those pieces equal to 0. So when I have it in one term, I can set, it's not as obvious, but I can set that equal to 0, I can set that equal to 0, I can set that equal to 0. Get each of my answers from there. You gotta be freaking kidding me. Wait, but the timer's not running. But... Oh yeah, it is. That's when I switch back from like mouse to not mouse. Alright. So how do you doing? Then second, they're both chain rules though, so I'm going to need to use product and chain combined. So the second thing times the derivative of the first thing, but I need a product rule here, I need a chain rule here. So I'm bringing down the 3, leaving the inside alone, reducing the power by 1. And don't forget to multiply by the derivative of the inside. That's like by far the most common mistake I see. Because you get like this product and chain, and this part of the chain rule, there's just so much going on, it's easy to forget that one little, the derivative of the inside there. Plus, the first thing times the derivative of the second thing. And again, make sure you remember to multiply by the derivative of the inside. Alright, so then I got these two terms. So there's one term here, and there's one term there, and I'm looking for what's in common. So 4x plus 1, I've got 5 of them there and 4 of them there. That means I can take 4 of them and just yank them out in front, reverse distributive property. X to the third minus 2. I've got 2 there and 3 there, so I can take 2 of them. And now you're looking at each term, so let's say I look at that term, and after I take those out, what's left? Well, there were 5 of these, I took 4 of them, so now there's just 1. There were 2 of these, I took 2 of them, so now those are gone. And then this, I can just kind of, I can be like, okay, that's 9x squared. And that's what's left from your first term after I factor out the stuff in front. Questions there? Then do the same thing with the second. So I took 4 of the 4x plus 1s and put them out in front, so there's none left here. I took 2 of these and put them in front, so there's only 1 left there. So I could just write this as x to the third minus 2, and then 5 times 4, I can just say that's 20. And then let's simplify the inside also. So this would be 36x to the third plus 9x squared if I distribute there. This would be 20x to the third minus 40. You guys with me? So if I add those up, 56x to the third plus 9x squared minus 40. What do you have that? Questions on it? If you didn't get it, you know where you went wrong. Okay. Play out when I was looking at yours, I like get some students to or put it out. So. Anything I can help with on this one? So, no, it'll be a little bit easier. So sometimes you only have to do the chain rule once. So you can get something that looks like this. Want to try it or want me to run through it? Try it. So, first thing, second thing. So the second thing times the derivative of the first thing. The derivative of the first thing is 4. Leave the little guy alone. Reduce the power by 1. Multiply by the derivative of the inside. So that's your 2. All of that is your d1. Plus 1 d2. So you rewrite the first thing times d2, which is just 2x. Which is a nice relief. So that's 1, and that's d2. And then you're looking for chunks you can pull out. The only chunk I can pull out is that 3x to the third minus 6, and how many can I pull out? 3, right? And then I got 2 terms. So this is one of my terms, but I just took those 3 away. So what's left is this x squared plus 7, and then that's 36x squared. Plus, then in this term, I took 3 of those away, so all that's left is 1 of those, and then the 2x. Again, the most common mistake I see is you do all this stuff right, but you forget to multiply the chain rule part, the derivative of the little guy. So you forget this, like the du essentially here and or here. So make sure you have those. And then we're gonna just combine the stuff on the inside. So if I distribute there, it's 36x to the fourth plus 252 x squared plus 6x to the fourth minus 12x, and then just combine those. So you have this, and then 42x to the fourth plus 252x squared minus 12x. How many have that? Questions on it? Where'd you get this from? I guess I'm different here. To be a little more complete, the AP test might actually write it like this. I don't think it's that hard to go from one to the other, but just to show you. So do you see what I did there? I took it, because this is not like fully factored. I could take a 2 and an x out of each of those three, so I put the 2x out here, and then reduced it there. You don't have to do it, you just have to recognize if they do. So like if you got to this answer, and one of the multiple choice answers was this, I think you would be able to match those up, right? Question on this guy?